Welcome you all to the new video session. Today we are going to learn a quite interesting topic called merge sort. Merge sort is used to sort an unsorted array. And for this purpose, it uses a technique which is known as divide and conquer. So, we are going to use divide and conquer principle to sort an unsorted array. And the name of this sorting technique is called merge sort. Let us move directly to the problem. Suppose we are having an array called A. As you can see in the example, we are having altogether 6 elements in the array. Along with the elements of the array, you can also see the positions of the array. There are altogether 6 positions numbered from 1 to 6. Leftmost position of the array is labeled as L and the rightmost position of the array is labeled as R, which clearly indicates that L points to position 1 and R points to position 6. Now, merge sort says that if the array is big enough to be sorted immediately, what we have to do? We have to split the array into 2 halves, as we have already learned in the divide and conquer technique, which was explained in the previous video session. It clearly says that if the problem is big enough to be solved directly, it should be split up into 2 halves. So we have come across such a problem here. The array is big enough to be solved directly, so I have decided to split the array into 2 halves. Now, how do we split the array? To split the array into 2 equal halves, we must find the mid position of the array. How can we find the mid position of the array? We have an equation, and the equation is L plus R by 2, which means adding the left position and the right position of the array together, and the sum should be divided by 2. The result will give you the mid position of the array. Let us check how. We know that value of L is now 1, value of R is now 6, because L points to the first location and R points to the 6th location. Definitely value of L and R are 1 and 6. So L plus R by 2 will give you 1 plus 6 by 2. 1 plus 6 by 2 means 1 plus 6 will give you 7, which means 7 by 2. 7 by 2 is 3.5. Is it? So, mid position is 3.5. If you get a decimal value, then ignore the decimal portion. You need to only take the integer portion, which is 3. So, we conclude that when value of left is 1 and the value of right is 6, the mid position of the array is computed as 3. So, now we know that value of m is 3. Once we get the value of m, it should be labeled. Let me label m at position 3. It means we had an array. It was having 6 elements in it with 2 pointers L and R pointing to the left and the right extremes of the array. Using those 2 values, I had computed the value of mid, and mid is now pointing to 3. Now what? After computing the mid position of the array, we should divide the array into 2 equal parts. Now, if I am going to divide the array into 2 equal parts, which elements will be moved to the left array and which elements will be moved to the right array? Okay, so for that we have a solution. We say all the elements from left end of the array to the mid position of the array. I repeat, all the elements from left end of the array to the mid position of the array will be moved to the left array, and all the positions from the very next position, that means position mid plus 1. If elements up to the mid position are moved to the left array, then the element starting from the position mid plus 1 to all the elements up to the right end of the array should be moved to the right array. Okay, so let us do that. If this is mid position, then we split the array into two halves such that elements ranging from left to mid position, that means all these three elements, will move to the left array, and all the remaining elements, that means elements from mid plus 1th position to the last element, okay, will be moved to the right array. So we got two new arrays with three elements each. Clear? Now instead of one array, one big array, we are having two smaller arrays. Again check if they are large enough. Yes, they are still large enough, because the first array is having again three elements in it, and the second array is also having three elements in it. Let us mark the positions. The positions of left array has been marked as 1, 2, 3, same as the previous positions, and the right array is also having the positions as 4, 5, 6, which are same as the previous array positions. Now as we got two new arrays, this is the left end of this array, this is the right end of the array, this is the left end of the right array, and this is the right end of the right array. Since we have two new arrays and they are still large enough, we have again decided to find the mid positions of the arrays. Let me take this array first. When we take the left array, we find that the value of L is 1 and the value of R is 3. To find the mid value, we need to add these two values, left plus right, that means 1 plus 3 by 2. 1 plus 3 is 4, 4 by 2 is 2, which means this is the mid position of the array. Similarly, let us take the right array now. When we take the right array, value of L is 4 and value of R is 6. To compute the mid position of the array, we need to add these two values, L plus R by 2. So we compute L is 4, R is 6. So L plus R by 2 will give you 6 plus 4, 10. 10 by 2 is 5. So we got the mid value as 5. Let me label the mid position. Okay. So now we got the mid position. After computing the mid position, what should we do? We should divide the array into two equal halves. How? All the elements from left to mid will go to left array and all the remaining elements will go to right array. In this array also, all elements from left to mid will go to left array and all the remaining elements will go to right array. So let us split the array. So we have split the array into two, and as a result we got 4 sub arrays. Okay, see, these two elements went to left array and the remaining element went to right array. Similarly, these two elements went to left array and the remaining elements went to right array. In this way, in each iteration, if the array has more than one elements, it is large enough. So, using the values of L and R, compute the value of M, label it. After finding the value of mid position of the array, split the array into two halves such that all elements ranging from L to M that is left to mid, should be moved to left array, and all the remaining elements should be moved to right array. Continue this process until we get all the arrays with 1 elements each. Clear? So now we have reached the third level. In this new level, we are having 4 arrays. First array is having 2 elements. It is still large. Second array is having only 1 element. It is small and need not require any division. Third array is having again 2 elements, which requires to be divided further. Fourth array is small enough, having only 1 element, so it does not require any division. So out of these 4 arrays, this array and this array should not be further divided, but these 2 arrays need to be divided further. Let us divide this array. When we consider this array, value of L is 1 and value of R is 2. To find the mid position of the array, we need to compute L plus R by 2. L plus R by 2 will give you 1 plus 2 by 2, which is 3 by 2. 3 by 2 is 1.5. When you get a decimal value, ignore the decimal portion and take only the integer part, which is 1. So while taking the first array, we get the value of mid position as 1. Let us mark the value of M. M is marked as 1. And what about this array? When we take this array, L is 4 and R is 5. Computing the value of M, we get L plus R by 2, which is 4 plus 5 by 2. That is 9 by 2. 9 by 2 is 4.5. Ignoring the decimal portion, we will get the value of M as 4. Let me mark the mid position M. So we have decided to split this array and this array. First, let us split this array. As I already told you, after computing the value of M, all elements ranging from L to M, that is from the left end to the mid position, should be moved to the left array. Since both L and M point to the same location, only this element will be moved to left array and the remaining element will be moved to the right array. Similarly, this array does not require any division since it has only 1 element in it. What about this? When we take this array, since L and M point to the same location, while splitting, all the elements from left end to the mid position will be moved to the left array. That means only this element will be moved to left array and this element will be moved to the right array. This array does not require any division. So altogether we got 4 new arrays. When we consider this array, it has only 1 element, no further division is required. This array also contains 1 element, no further division is required. This array also contains a single element and this array also contains a single element. So altogether, even though we are having 4 sub arrays, each of them are having only 1 element in each. None of them require to be further divided, so the division section has come to a stop. Now the reverse process starts. In this way, in each iteration, we must split the array into 2 equal halves depending on the value of M computed using the equation L plus R by 2. Continue dividing the array and splitting the arrays into left and right arrays until every array in the level has only one element in it. When you stop dividing the arrays, the second half begins, that is conquer part begins. And the conquer part says that you have to apply the technique called merging. Now how to do merging, or what is merging? The concept of merging has been clearly explained in my previous videos. You can refer to that. Merging says two sorted arrays can be combined together to give a single sorted array. Let us see how this can be done. Remember, if the division process proceeds from top to down, then the conquer part proceeds from bottom to top. That means now we are moving from the last level to the first level. Let us see how are we going to do this. Let us begin from the last level. In the last level, we are having 4 arrays, and every array is having only one element in it. Since they are having only one element in it, every array is sorted in its present state. First array having only one element, which is 7, it is sorted. Second array having only one element is 1, again it is sorted. Third element is having element 9 in it. Element is, since it has only one element in it, the array is already sorted. Fourth array is having an element 3 in it. Since it is having only one element in it, that array is also sorted. So, let us take two sorted arrays together, merge them to get a single sorted array. So, I have decided to take these two arrays. I am going to take these two arrays. By the process of merging, this array and this array can be merged together to get a single sorted array. That means the result of merging will give you an array which consists of all the elements of the previous arrays, but the result will be in a sorted form. So, instead of 7 and 1, the array elements will be now 1 and 7. Hope you understood the concept why it is written so, because the inputs were having two arrays. Each of them were individually sorted. When these two arrays are combined using merge operation, the result we get is also a sorted array. So we got a new array with the elements 1 and 7. Similarly, let us take these two arrays. When these two arrays are taken and they are merged together, result of merging will give you a new array whose elements are also sorted. So instead of 9 and 3, we will get the value as 3 and 9. And from the last level, we went to just previous level. Now we are at this level. In this level, we are having 4 arrays. First array is having 2 elements in it. Second array is having only 1 element in it. Third array is having 2 elements in it. And the fourth array is having only 1 element in it. Let us take 2 arrays together at a time. Check if they are sorted or not. I have decided to take these 2 arrays. First array is sorted and the second array is also sorted. I have decided to merge these 2 arrays. While merging these 2 arrays, the result of merging is also a sorted array. So when these 2 arrays are combined together using merge operation, instead of 7, 1 and 6, the elements we get will be 1, 6 and 7. Similarly, Let us take these two arrays together. When these two arrays are combined using merge operation, the result should also be a merged. The result should also be a sorted array. So, when 3, 9 as an array and 5 as an array are combined together using merge operation, instead of 9, 3 and 5, we will get the elements 3, 5 and 9. So like this, we entered from this level to this level. Now at this stage we are having two arrays. First array is 1, 6 and 7, which is sorted. Second array is 3, 5 and 9, which is also sorted. So we are having two sorted arrays. These two sorted arrays can be merged together to get a new sorted array. So after the merging operation, we will get the elements as 1, 3, 5, 6, 7 and 9. So in this way, we moved from this level to this level. Finally, we are at the starting stage again. So in this way, merge sort divides the array into two equal halves, proceeds the division until we get smaller arrays of one element each. Once we come to a stop of division process, we begin the merge operation. In merge operation, from each level, we take two arrays at a time, which are already sorted. We combine those two arrays together to get a single sorted array. The process proceeds from the last level to the first level. Finally, we will be having a single sorted array. So in this way, we can use the divide and conquer method to find the solution to merge sort, which clearly sorts an unsorted array. Hope the concept being explained using this video has been clearly understood to all of you. Keep watching the videos and support me.